Hey guys, BuildZoid here, and today we're going to be taking a look at the first X870 memory overclock that I've set up with the Ryzen 9 9950X. So the setup here is a Crosshair X870E Hero motherboard, which was provided by ASUS, so a big thank you to ASUS for the board. And the memory kit I'm using is a Corsair Vengeance 2x48GB 6000 CL30, is it Expo? XMP memory kit, not that it matters. Yeah, so 2x48 gig Corsair Vengeance RGB memory kit, which was provided by Corsair. So big thank you to Corsair for the RAM. And the CPU, the 9950X, I had to buy that. So a big thank you to the channel supporters for making purchases like that possible. Now, unfortunately for me, the 9950X that I bought is pretty, like, I'd say its one-to-one mode is actually pretty strong. Like, it's way better in one-to-one mode than any of my other Ryzen CPUs. Unfortunately, the two-to-one mode is horrendous. And I still need to do some more testing on that, but at this point, I've basically completely ruled out any possibility of DDR5-8000 ever working on this CPU unless like something drastically changes with the AGSA or with the BIOS tuning from the motherboard vendors, because as of right now, the best case scenario for this 9950X at DDR5 8000 is that it just randomly reboots the entire system when running stress tests, which is very weird. And I know that I've not found a fix for it. Like, yeah, like it's just I think the longest I've managed to have this chip run without a reboot is like 30 minutes, which is, and when I say without a reboot, I mean like the CPU just crashes so hard that it just restarts the entire like the motherboard just restarts itself while running a stress test. So, yeah, so I've given up on that and instead decided to go with this like relatively high capacity one-to-one setup, because the 9950X is really kind of more of a workstation CPU than a gaming CPU, and so I imagine a lot of people might actually be considering something like a 9950X with 96 gigs of DDR5. So that's what we're looking at here. And in one-to-one, and obviously this runs best in one-to-one mode, so that's what we're taking a look at here, which does make for a pretty bland memory setup in my opinion, but like at least it works compared to the 2-to-1 stuff that I've been testing with this chip. So yeah, here we are. So 6400 CL32, because this is a dual rank DDR5 kit. Like even with the fan, I mean it didn't run that hot, but dual rank DDR5, it does run hot. Because you have memory chips on both sides of the memory stick, and so the temperatures are higher. Also, this is an RGB kit, which really isn't helping the temperatures. So yeah, I decided not to like push the voltages really high, which doesn't really affect the subtimings, as you'll see. But it does mean that like the primaries aren't like super crazy tight or anything. So yeah, so we've got 6400, 32, CL32. Actually, we should go through the stress test first. So Carhu, 16 hours, 38 minutes, no errors. So that's cool. Ran some Y Cruncher, so that's over 2 hours. And this is an experiment. Like I've heard from some people that like FFTV4 is like hard. Probably should have checked that in like 2-to-1 mode instead of 1-to-1 mode, because yeah, in 1-to-1 mode, and this is what I really like about one-to-one mode. If your like with one-to-one mode, basically the only thing you really have to worry about is having your SoC voltage high enough to run whatever UCLK you're at, and then not setting your FCLK too high. And what I mean by not setting FCLK too high is the FCLK has error correction. And if you set the FCLK too high, it will just retransmit data over and over and over again until it gets through, which basically means if you set your Infinity Fabric too high, you're not necessarily going to immediately run into like crashing and instability. You're going to first run into performance loss and like hitching and stuttering and just weirdness. So setting the FCLK too high is like a real concern for really any mode, but in one-to-one mode, it's especially bad because the high SoC voltage tends to negatively impact Infinity Fabric stability. So Yeah, but outside of that, like one-to-one mode is basically just set the SoC voltage high enough that you can run whatever UCLK you're aiming for, which for 6400 is 3200, and this CPU just so happens to do that at like 1.2-ish volts. Um, I have other chips that even with 1.3 volts will not run 3200 UCLK, right? So that makes one-to-one mode overclocking kind of boring, but also really like nice because it either works or it doesn't, and I like that. I don't like having my RAM stability in a superposition. That's not fun when it randomly works and then randomly doesn't. Um, so anyway, yeah, so like so kind of a bland overclock in my opinion, but I mean, if you're running 96 gigs of DDR5, you probably want your system to run rather than to crash. So, but anyway, so yeah, Y-Cruncher VT3. So this is technically like less VT3 than I usually run because I'm mixing FFT V4 into it. So I'm not sure if this is actually like a good alternative to VT3 because I've heard like in the past I've heard from multiple people that like, oh, there's other tests in Y-Cruncher that are like better than VT3 or like that you should mix with VT3, but in my experience usually just running pure VT3 tends to be tends to crash faster than any kind of mixed workload of Y-Cruncher does. um so yeah, so this is like an experiment, but like it passed, so for whatever it's worth. As another experiment, I also mixed in Prime 95 large FFTs. So you can see that I started it at the date time thing is completely out of whack, but you can see that it started at 1800 and then it ended at 52. So that's like 4 hours. No, that's like 6 hours, isn't it? Because that's yeah, so that's like 6 hours of Prime 95. And I will say that Prime 95, and when I was messing with 2-to-1 mode on this CPU, Prime 95 large FFTs is a viable memory stress test. Like it will crash if the system isn't stable. Now I'm not sure if it's like better or worse than VT3. I will say though, what I did notice with this is Prime 95 large FFTs runs the memory like power consumption right up there, which VT3 on Ryzen systems kind of doesn't. So that's interesting. Now, the funny thing is like having the highest possible power consumption doesn't automatically make something a better stress test. One of the funny things about Y-Cruncher is that it is potentially like on CPU stability, it's often harder to pass than things that pull more power just because of the load cycling that Y-Cruncher has, which large FFT's Prime 95 kind of does as well. But I've not tested them against each other a bunch, but I do think Prime 95 large FFTs is a good alternative to like Y-Cruncher VT3. So like it's certainly viable. So I wouldn't if you don't want to deal with like setting up Y-Cruncher or whatever, you could just do Prime 95 and then it's what was it? Options, torture test, and then you just check large FFTs and just run that. Now I'm not going to do that right now because then it's going to reset all of the statistics that I have here. But yeah, so all of the tests passed, and I manually stopped the test after 6 hours. Anyway, temperatures on the memory maxed out at that's a funny sensor glitch. That's a new one. I've not seen that one before. I'm used to the like there's a sensor glitch that like you'll get like 63.9 degrees very consistently. It's something like that. It's like just over 60 degrees. And there's one more that's like just I think it's like 47.9 or something. Like there's a couple like there's like two temperature glitches that happen with DDR5 that are like relatively low, but this is a new one, 3577 degrees. Yeah. Not seen that one before, but that's obviously glitched out, so that's annoying. But the other memory stick maxed out at 47 degrees, and during testing, the room temperature was around 20 degrees. And that's the thing with the dual rank DDR5 DIMMs. Like I have a fan on these. Now admittedly this is not the highest airflow fan. Also, if you're wondering, that fan is held in place on like super tall motherboard standoffs. Actually, I'll grab one just to show you. So, because like if you're like that fan isn't literally sitting on the memory sticks, it's attached to one of these. Well, it's like screwed down on one side, and then the other side is actually just sort of sitting there. So that's kind of like a neat trick. Is that I think it's 80 millimeters. 80 millimeter fans actually will just bolt straight to the motherboard mounting holes if you have like really tall standoffs. I'm kind of surprised that no motherboard vendor has like offered that as like part of their accessory package, because I've seen like a bunch of random like memory fan mounting kits for like small 40 millimeter fans or whatever, but you can just bolt a 80 millimeter directly to the board using the standard standoffs. Like I've been doing that for ages now, and it's just, yeah. Anyway, but yeah, so even with the fan, the one memory stick that didn't have the temperature sensor bug out, like it maxed out at 47 degrees in a ambient air temperature of like 20 something. So if the ambient temperature was a bit higher, that memory stick would be at like almost 60 degrees, right? And we're only at like 1.4 volts on the memory, so it's not like I'm not pushing this memory super hard, and it is running pretty warm because it is dual rank, right? And now it's not really a concern for most of the timings, but for refresh interval, if your memory temperature gets much above, it kind of varies by memory stick, but for 65,000 refresh interval, if you get above like 55, 60 degrees, you're going to start seeing errors. And on some kits, it might even happen at like 50 degrees. So, yeah. That's one of the other reasons that I decided to sort of not go ham on the VDD. Because while it might be possible to run lower cast latency if I raised the VDD a bunch, it's not actually going to change the performance very much, and it's going to drastically increase the temperatures, and that might negatively affect refresh interval. And refresh interval is significantly more important than cast latency. Especially when it's like two ticks of cast latency. Like, that's just not worth the trade as far as I'm concerned. Anyway, so that's the memory temperatures and the memory cooling. And then, yeah, you can see that Prime 95 large FFT's also got the CPU temperatures like way up there, which is really impressive. Normally things that use the memory a lot struggle to get the CPU really hot, especially on Ryzen, because the memory controller is not very high memory bandwidth. But yeah, Prime 95 got the CPU temp way up there. Memory temp also like not. I don't think it was quite as high as Karhu, but also like still pretty high. So yeah, I would say like Prime 95 large FFTs, if you want an alternative to Y crunchers, like it is an alternative to Y cruncher. Just like keep in mind that your CPU power consumption while running this is going to be ridiculous. And on an Intel system, it'll probably be even worse. Because yeah, here it was pulling like 200 watts on an Intel system. Well, I mean, depending on if you have the power limits turned on or not. But if you don't have the power limits turned on, this could easily end up going like 300 watts or higher. So, yeah. Anyway, so that's all the stress tests, right? Like Karhu passed, Prime 95 passed, which is a new one that I don't usually use. And then, of course, we have Y cruncher passed as well. There's the Zen timings, if you just want to copy them. And then, of course, the memory kit. And again, like with the memory specs, Expo, like, I don't think Expo matters, but I might, like, I don't really have as well, at low speeds for 1-to-1 mode, like, just buy a 6000 CL30 kit, as far as I'm concerned. Like, there's no point to pay, like, unless it's cheaper, because, like, sometimes you'll, like a 6400 CL32 kit might be on sale or something. I would not buy a 6400 CL32 kit or a 6400 CL whatever, really, if it's more expensive than a 6000 CL30 kit for Ryzen. And the reason for this is very simple. You can, even with 9000 series, you can get really unlucky and end up with a chip that will simply not run DDR5-6400, because the amount of SoC voltage you need in order to run 3200 at UCLK is like more than 1.3 volts, and the current limit in the AGSA for SoC voltage is 1.3 volts, because more than that was breaking CPUs. So you know, like I don't think it makes a lot of sense to buy a memory kit that isn't that like there's a chance like there's like a decent chance that it's not going to work on the default settings of that memory kit. So I think it makes way more sense to always just buy for Ryzen, just always buy a 6000 CL30 and then manually tune it instead of buying a like something higher spec and then, you know, having to potentially turn it down instead of turning something cheaper up. Because at the bare minimum, the 6000 CL30 kit will at least work out of the box. I don't think there's like any chance that you'd get a 6000 CL30 that wouldn't work unless it's actually defective, right? Whereas if you buy a 6400 CL32 kit and then it doesn't work, well, you don't know for sure if it's the memory's fault or if it's the CPU's fault. And that is even more true the higher the speed spec of the memory kit is. So anyway, yeah, that's all the stress testing. Oh, also, of course, no errors in here. But Ryzen 9000, well, 7000, I don't know if 9000 is the same. It probably is, but 7000 doesn't really spit out errors, even when like your Infinity Fabric is unstable. Like Ryzen 5000, if your Infinity Fabric is pushed too high, you're going to get a ton of Windows hardware errors. Ryzen 7000 doesn't do that. You just get stuttering, hitching, performance loss, and then if it's really, really unstable, it'll actually reset the entire system. But if it's less unstable than that, it will just cause weird issues if your Infinity Fabric is unstable. So, yeah, unfortunately, like I think this will like this might catch like excessive undervolts on the CPU cores, but for verifying the Infinity Fabric stability, this, in my experience with 7000 series, is useless, and I'm assuming for 9000 series, it's also going to be useless. So, yeah. Anyway, so that's that for the Windows portion of the video. So I guess let's restart and go into the BIOS. And I should have fast boot turned on, and hopefully it won't break. Unfortunately, and I'm not sure if this is ASUS motherboard specific, or if this is like, and it might, like, basically I've run into some weird issues where like sometimes the motherboard just like doesn't reboot properly. And then you need to like clear CMOS. I don't know why. Oh no. Well, fast boot is so fast that I missed the BIOS. Actually, I was holding the delete key. Just like fun fact, holding the delete key, like if you press it too early, it doesn't work. Is my experience. Which is why I always mash the delete key. And yes, I know there's like a command line thing you can do to get booted into the BIOS. I just kind of don't remember where I put that, like where I put it, because I do have a batch file for it. And I forgot to use it, like I didn't remember to use it anyway on the OS I had with it. Why is Windows being... Like, this system uses a SATA SSD, but, like, it shouldn't take that long. Okay, this time I got it. Anyway, so here we are in the BIOS. As you can see, I have DOCP turned on. Not that we're actually like using it or any... Wait, did I just... I might have just overwritten my memory settings. Oh, yeah. Yeah, I did. Okay. Anyway, so I have DOCP turned on, but we're not actually really using it. That's just like, I usually like to start with like, you know, turn on the XMP or Expo, which ASUS calls their like XMP translation system DOCP. But anyway, so you just turn that on. And it's not even really a translation system because like XMP isn't like encoded or anything, right? Like it's just a string of numbers in the SPD chip that any motherboard can read because they're not encrypted or anything. So like, but anyway, so yeah, I usually just start with like turning on the default settings of the memory kit just to check that, hey, that works, and then work from there. So that's why DOCP is turned on. Then we have DDR5-6400 set, FCLK at 2133. Now the reason for the 2133 FCLK is that there is a slight, and it is very minor, but it is measurable. There is a slight latency advantage to having a 3:2 ratio. So if you go 6400 divided by 3, you get, yeah, 2133. And actually the reason I say 3:2 ratio is because technically the 6400 megatransfers per second is actually 3200, right? So it's actually like divide by 3 times 2. 2133. Because the thing is, when you're in one-to-one mode, the Infinity Fabric, like, it never synchronizes to the memory controller, because the memory controller, like, in this configuration, the memory controller runs at 3.2 gigahertz, which is not too, like, I'm not even sure we have a 3... Yeah, we don't even have a 3.2 gigahertz option for the Infinity Fabric, and if we did, it wouldn't work. If you get, like, incredibly lucky with a Ryzen 9000 or 7000, it might run 2233. So, yeah. 2133, on the other hand, is actually quite common. It's like, I'd say 2133 FCLK is actually more common than CPUs capable of running 6400, which is not really that helpful. But so if you're in like 6200, you're often going to be like running like 2166, 2200, or 2066, right? Because that again gives you that 3:2 ratio. And anyway, this CPU does do DDR5-6400 and 2133, so that's like the optimal setup here. Then voltages, SoC voltage at 1.22. This varies by CPU a lot. Like there are some chips that, you know, even if you set this to 1.3, won't do 6400. They just won't. And there's like nothing you can do about it other than like buying more CPUs. And then there's other CPUs. Like I think I've seen a couple chips that'll do like 1.17 or something for 6400. And those are really, really good. Those are the kinds of chips that can actually run DDR5-6600 1-to-1. Mine, unfortunately, isn't one of those. It needs a little bit too much voltage for 60. Like at 6600, it doesn't work at 1.3. So yeah. Anyway, but at 6400, it doesn't need a ton of voltage because that's just like the silicon lottery at play there. For VDDIO, 1.4 volts on this BIOS version that I'm using, which is 0505. This seems to work best, at least, well, in 1-to-1 mode, it doesn't really matter that much what VDDIO you use. But even in 2-to-1 mode, when I was experimenting with this board, it would generally prefer higher VDDIOs. So I didn't really see a reason in 1-to-1 mode to like try run a really low VDDIO or anything, because this works fine. There's not really like, I don't, you know, it works. I don't see a reason to fix it if it's not broken. And also, if you're in 1-to-1 mode, there's probably going to be a pretty substantial range of VDDIO voltages that do work, because the signaling requirements in 1-to-1 are significantly less stringent than in 2-to-1 when you're pushing very high memory speeds. So that's like one of the upsides in 1-to-1 mode, is that a lot more stuff works, so you don't have to be as like careful with tuning things. And also 1.4 VDDIO is not going to hurt the CPU. It's not a concern. VDDP, 0.95 volts. For 1-to-1 mode with this CPU, that seems to work great. So that's what I'm going with. DRAM VDD at 1.4, VDDQ at 1.4. Like, it's an ASUS board, and this is basically another case of, like, we're in 1-to-1 mode. It doesn't really matter that much what exactly these voltages are. Though I will say on this BIOS, this board does tend to prefer higher VDD queues, which is just like, and by higher, I mean around 1.4. Because like I've seen other motherboard, like there's motherboards from other manufacturers that work best at like 1.3 volts or something. Yeah, and that can also sometimes change with the BIOS versions. Like on some BIOS versions, it's like high signaling voltages versus other BIOS versions, low signaling voltages. And by signaling voltages, I'm referring to VDDQ and VDDIO, because those are the two voltages that are actually used for like the signal between the memory controller and the memory sticks. VDD is internal to the memory chips. It doesn't go outside the memory chips. So VDD is primarily for like running lower timings, which really just means lower CAS latency. It doesn't actually affect much else. So anyway, so that's the voltage setup, and then the VDDGs, I just left this on auto because for the settings that we're running here, they're not really, like, we don't have to worry about those at 2133 with the CPU. So anyway, let's go through the memory timings. So I didn't really fine-tune these, right? So this is just 32, 38, 34. There's a decent chance like 34 TRP would work. With a bit more VDD, we might be able to do CL30. With a lot more VDD, it might do CL28, because this is 24 gigabit MDI, so the requirements for like CL28, like I would guess CL28 would probably require somewhere around 1.6 volts, maybe more, because MDI is weaker on, well, generally weaker on primary timings than ADI is. So anyway, but like the thing is, like tuning the TRP, like it would give a little bit more performance, but not a ton, which is why I didn't really bother with that. Also, some kits can do like TRCD 37 and 6400, but I didn't feel like taking my chances after spending so much time suffering in 2-to-1 mode. Like, this setup here that we're looking at was like, I just want something that works, and I don't want to like, you know, like a return to sanity. Just punch in some nice, safe settings, and it'll work. And I won't have to... won't have to like suffer anymore with this CPU's memory controller. So that's why the primaries aren't like super optimized. Well, the thing is, when I say like they're not super optimized, like we're basically like TRP really doesn't matter that much for primary, like for performance. Like yeah, it would be slightly faster if it was lower. Not really but you'd need like some really memory sensitive benchmarks to actually, you know, check that. TRC at 68, because it's just TRAS plus TRP. TWR 48, refresh interval 65,000. Like I mentioned earlier, what refresh interval you can run is almost entirely dependent on the memory temperature. So if your memory sticks are really hot, you're gonna probably end up having to run a lower refresh interval, like say 50,000. But even at 50,000, like 50,000 should get you up to some really high memory temperatures. Like it shouldn't have issues even up to like 60 degrees or higher. Whereas 65,000 can get kind of questionable depending on the memory sticks. Once you start going over much over like 50, 55 degrees Celsius. TRFC at 555. These two, as far as I know, they're still not being used. I haven't actually verified that for 9000 series, but with 7000 series, these didn't do anything. With 9000 series, I don't think they do anything either. And we have RTP at 12, TRRDL 10. This is a 24 gigabit MDI thing. It just doesn't do TRRDL as low as 16 gigabit ADI does. Not a big deal, but something to keep in mind. TRRDS at 8, same thing again, like 24 gigabit MDI just doesn't do TRRDs as low as 16 gigabit ADI does. And then we've got TFAW at 32, because setting, like, technically, we could set it to like 20 or something. It wouldn't actually do anything in this scenario, because our TFAW is, like, TFAW only applies if it's higher than the TRRDs, right? Than the shortest of the TRRD timings times 4. And since TRRDS is 8 times 4 is 32, setting TFAW below 32 doesn't do anything. But we also definitely don't want to set TFAW above 32 because that hurts performance. So Anyway, TWTRL at 14. This is probably about as low as WTRL is going to get at 6400 with 24 gigabit MDI. WTRS at 4. RDRDSCL at 4. Some CPUs will struggle with this at 6400. And maybe some memory kits as well, where like the read-to-read SCL, you'll sometimes have to run it at like 5 or 6 when pushing the higher memory speeds for one-to-one mode. I've not run into that myself yet, but I've heard from other people that they have like memory kits where it's like, oh, it only works at like 6 RDRDSCL for 6400, even though 4 works at like 6200. And I think that's like, it could be a memory kit thing. I think it's probably more likely to be a memory controller limitation. But yeah, I've not run into that myself, so I'm not, can't really test can't really test that. Then we have read-to-read SD and DD. So technically, the way I'm setting these, also I just noticed that like the capitalization is inconsistent, and I don't like it. We have a capital S, but then a lowercase d. I do not approve. But anyway, so SD stands for same DIMM. So this is referring to the other memory rank on the same memory stick, whereas DD stands for different DIMM. So if we look at the board, right, this is a dual rank setup because we've got 48 gig DIMMs using 24 gigabit memory chips, which basically means each of our memory sticks has 2 ranks on it. So SD means same memory stick, right? So it's rank 1, and like you'll have like rank 0 and rank 1 on the same DIMM. So for this setup, technically speaking, the only relevant timing is RDRD SD, not DD, but I'm lazy and I like to set both of these, because if you set both of these, regardless, like if this, instead of being a 2x48 setup, if this was a 4x24 setup, which I would highly recommend you don't do because it's not ideal. Like it can work, but it's not ideal. Don't buy 4 sticks of DDR5. Just don't. I know your motherboard has 4 memory slots, and that is a design flaw, not a feature. Anyway, but if you had like a 4x24 setup, then the relevant timing would be DD. And by setting both of these to the same thing, you don't have to think about it, right? Like I just sort of treat them as like these are both timings that only apply to multi-rank setups, and they're the same. Is like the way I approach that. Right to right SCL at 2. Right to right is kind of weird on AMD because like a lot of the time you can just set it to 1 and it'll still work, which I kind of suspect is because the memory controller just doesn't have enough write operations to actually hit the limit of that timing. Yeah, I haven't been able to like verify if that's what's going on with that one yet. I'm not even sure how you would verify that. But anyway, and then we have right to right, same DIMM and different. Man, it's even more inconsistent. Okay, now I'm really annoyed. This one gets capital D, but this one doesn't. What? ASUS, why? Anyway, so same approach with these two. Again, just set both to 8. And it's worth noting the write to write with DDR5 is slower than the read to read for different ranks, which is kind of wacky considering that the write to write on the like same memory rank is really quick. Yeah, that's just a thing. Is that sending write operations to 2 different like sending a write to one rank and then sending another write to a different rank, it just takes longer. If you set these lower than this, it probably won't even post. Like you won't even get to check if it's unstable because it won't even get into Windows. So yeah, so this is like the minimum like timings for dual rank setups is basically read to read 6, at least at this speed. I think if you were at much lower speeds, it might be possible to run these lower, but I haven't like tested for that. Like at 5600 or something, it might be possible to run these lower. But at 6400, 66, 88, Also for 6200, it's the same thing, 6688 for the write to writes and read to reads. And then write to read and read to write, just 416. These two aren't minimized. They could probably go lower. Like this could probably be a 2. Actually, read to write might not get any lower. That like pushing that one below 16 doesn't always work. But anyway, so that's the tertiary timings. And then for other settings, I didn't have to change anything. Well, other than setting UCLK equals MCLK, because if you don't do that, the board does default to 2-to-1 mode as soon as you go above 6,000. So yeah, you do like that's another reason not to buy a 6400 rated kit, because if you turn on the XMP of a 6400 or an Expo of a 6400 rated kit, on most motherboards, you're probably going to end up in 2-to-1 mode, and the performance is going to be terrible. It is literally slower than 6000 CL30 in 1-to-1. So, like, yeah. And you just have to keep that in mind, that you should, like, you know, turn this on. Also, if you check your, like, Zen timings will tell you if your memory is in 2-to-1 mode, so it's not, like, a big deal, but that's just something to keep in mind. And that's it. Yeah, that's it for the settings. If you want to be less worried about the stability of something, like if you want to copy these settings and you don't want to deal with any potential instability, you could just do this. There. Like 6200, 2066 Infinity Fabric, and 1.27 SoC. I would be very surprised if the vast majority of CPUs weren't able to run these settings with this adjustment of like slightly lower speed, more SoC voltage, because there are some really, really bad CPUs out there. I would know. I have one of them. It's currently recording this video. Yeah, then FCLK to 2066 for 6200. But if you have a better chip, then like 6400 really isn't a problem. And if you have a really, really good chip, even 6600 isn't a problem. But, you know, you need to get incredibly lucky for that to work. So, yeah, I wouldn't like, I don't have chips like that. So, yeah. Anyway, so that's it. Just, you know, 96 gigs of DDR5 at 6400 CL32 with, like, the funny thing is the subtimings are actually very similar to what I use for 6200 or even 6000. Because that's the funny thing, as a lot of the timings really don't, like, subtimings don't really get that much looser as you go up in frequency. So, yeah. Anyway, where's the system specs thing? There we go. So yeah, that's that. If you want like a workstation-ish setup, because obviously like there are applications out there that'll use even more than 96 gigs of RAM. I just don't know what they are. So, yeah, and also at that point, like your memory setup is going to be very slow. But you know, better than not having enough RAM. So, anyway, but yeah, so hopefully you found this somewhat useful, or at least interesting. Yeah, that's it for the video. So again, thank you to ASUS for the motherboard, thank you to Corsair for the memory kit, and a big thank you to the channel supporters for the CPU. And with that out of the way, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also like a Teespring store. Actually, no, it's not a Teespring store. There's like links in the description. Most of them should work. I would appreciate it if you check them out. And yeah, that's it for the video. So thanks for watching, and goodbye.